you demanded, I am Daniel Price, your instructor for this trig course. And I'll be honest with you, wow, who would be thinking that I'd be teaching trig online and having to shoot videos like this just a year ago? But regardless, I'd much rather this course be face-to-face, and this is not a bad way of doing it right here, because this video you're going to want to watch several times. So this is the face of your instructor. I was born in Portsmouth, Virginia. I moved back down here to Eastern North Carolina, joined the military. I got out of the military, graduated from ECU not once, not twice, but 3 times. I've been an educator in Martin County for a little over 20 years, been at the college for 10, in the National Guard, doing lots of different things, love cooking on the weekend. So what I'm going to do right now is not only let you see an introduction to me, but this is a video that you're going to want to watch 5, 6, 7, 8 times. You're going to want to show to your parents, your friends. Without this video, without the information in this section for the next 10 minutes, your journey on trigonometry ends. This is that important. This is why I'm shooting this video. So what I'm going to do, I'm going to talk fast, but like a good video, State Farm, wrong commercial. Like a good video, you can back up, you can pause it, you can fast forward past this 60-second introduction to who I am and my face. But let's get started. I'm going to talk for about 10 minutes very fast. This covers section 7.2. So what I'm going to do is start off with just a typical angle theta. That little circle with the little hairdo, that's theta. So if I decide to take this angle and construct a right triangle, a triangle with a right angle in it, I can look at this little angle and say, hey, look at this little opposite side to that angle. Look at this little adjacent side to this angle. And of course, the side opposite the right angle in a right triangle is, of course, the hypotenuse. Now, there's a couple things I do want to state, and I'm going to erase them off this board after I write them, is this. We should know the Pythagorean theorem by now, that given a right triangle, a leg squared plus the other leg squared is equal to the hypotenuse squared. So in other words, a right triangle with a side length of 4 feet here, 3 feet here, and 5 feet here satisfies that Pythagorean theorem. 4 squared plus 3 squared, 16 plus 9 is 25, which is 5 squared. Now what that really means is that 3 feet, if I construct a square which is 3 by 3 feet, and then I construct a square here which is 4 by 4 feet, so this area is 9, this area is 16, that is going to be equal to this square, which has an area of 25 feet. So some people don't see this picture, they just see the numbers in it, but it does relate to area. So let me get rid of that. So given a right triangle, in a right triangle, we know there's a relationship between the lengths of all 3 sides, and it's called the Pythagorean theorem. We also know that in any triangle, the 3 angles always add up to equal 180 degrees, whether it be right, obtuse, acute, whatever. But it is with trigonometry that we go and explore the relationships, not from the sides, and not from the angles, but from the angles and the sides. They do share a relationship. So in this right triangle, let me show you 3 of the most basic relationships. One is called the sine, S-I-N-E. Now in calculator, you'll see it abbreviated as the sine. The sine of an angle, the sine of this angle, remember what a function is in mathematics. You put in something and out pops something else. What is the function x squared? You put in a number, you multiply it by itself, you get x squared. That's a function. So in the sine function, you put in this angle, the sine does something to it, and out pops the relationship between the opposite side and the hypotenuse. In other words, there's a relationship that exists between this angle and these 2 sides. We also have one called the cosine, which is abbreviated COS. So the cosine of this angle is equal to the relationship between the adjacent side and the hypotenuse. And last but not least, we have that tangent, which is abbreviated TAN. So the tangent of theta would be the opposite over the adjacent. Now don't get caught up in what exactly these mean just yet. We're going to get to that. But one thing I want to stress to you right now before we go forward is that this opposite side is only the opposite side because it's opposite this angle theta. If I were to come up here and draw a new angle, maybe call it beta, with a little b with a little tail, beta, its opposite side would be this one, and the adjacent side would be the one touching it. The hypotenuse stays the hypotenuse. It's always opposite the right angle. So be careful. Which is your opposite side or adjacent side, or I should say opposite leg or adjacent leg, depends on which of these two acute angles you're at. So we're focusing on this one, that being the opposite side, the one away from it. Now here's one good way to remember these trig ratios. Some old hippie caught another hippie tripping on apples. Sakatoa. What you do when your toes are really sore, you soak your toes. So Sakatoa is a good way to remember these relationships very, very quickly. Now, what I'm going to do now is talk about a few other relationships. But I just really want to start envisioning what these really mean. When you take your calculator and you type in tangent 45 and press enter, if it's in degree mode, your calculator is going to give you 1. You're going, how is that possible? Well, let me draw a right triangle, which is a 45, 45, 90 degree triangle. And a 45, 45, 90 degree triangle, we're going to explore in the next section that, hey, if this is 7 feet, this is 7 feet. That's kind of like the isosceles triangle theorem. If two sides of a triangle are congruent, the angles opposite them are congruent. Or if two angles are congruent, the converse, the sides opposite them are congruent. So the hypotenuse would be 7 square roots of 2. But your calculator doesn't know which triangle you're referring to. So when you type in tangent of 45 degrees and press enter, your calculator is going to give you the number 1. Why? Because the tangent of a 45 degree angle is equal to the opposite side or leg over the adjacent leg. 7 over 7 is 1. Now what if you're dealing with a 45, 45, 90 degree triangle and this side happens to be 3.6 feet long? Well, then this one has to be 3.6 feet long. So the tangent of a 45 degree angle is 3.6 over 3.6, which is again 1. So regardless, it's not the size of the triangle that matters, it's the angle that you're dealing with. Well, I want to talk about a few more relationships real quick, and that's what this video was intended to be about. So not only do we have sine, cosine, tangent, we have what's called the reciprocal ratios. So sine's reciprocal is cosecant, abbreviated CSC, and the cosecant of theta would simply be hypotenuse over opposite. Cosine has a reciprocal, which is called secant, and it is hypotenuse over adjacent. And then last but not least, tangent has a reciprocal called cotangent, which everybody seems to remember that one, which is adjacent over opposite. I don't expect you to memorize that cosine is hypotenuse over opposite. My mind doesn't even allow me to do that. I can't memorize it. What I memorize is Sakatoa, these three right here, and then I remember that cosecant is the flip, the reciprocal of sine. Secant is, I can't even in my mind remember what secant's equal to. All I know is that cosine is adjacent. Some old hippie caught another hippie. Cosine is adjacent over hypotenuse. So what I do is remember that secant is the reciprocal of cosine, which is hypotenuse over adjacent. So you're not going to use these that often on your calculator, but we will use them in the future. Oh, look at this. Since we have these three, which are called the reciprocal identities, which are really cool, tangent is opposite over adjacent. Here's what's really cool. Tangent is actually also equal to sine over cosine. Sine over cosine. You're going, how did you get that? Well, if tangent is opposite over adjacent and sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, watch what I do. Sine was opposite over hypotenuse. cosine is adjacent over hypotenuse. So what happens here when you divide two fractions, you take the top one and you multiply by the reciprocal of the bottom one. That's the rule for dividing fractions. So these cancel out and you're left with opposite over adjacent, which is exactly what tangent is. And since that's tangent, we know that cotangent is the reciprocal, so cotangent of theta is not only equal to these sides, but it could also be called the cosine over the sine of theta. So that's pretty cool. So these are two more little identities. Pretty awesome there. Pretty awesome. There's another identity that I'm going to go into a lot more detail in the future, but it's this one. The sine squared of theta plus the cosine squared of theta equals 1. Now, I know this notation looks a little strange, but keep in mind, mathematicians are lazy. This is the same thing as the sine of theta squared plus the cosine of theta squared equals 1. In other words, what we're talking about here is that we're taking the sine of that angle and then we're squaring that quantity. We're adding the cosine of that angle and squaring that quantity. So it's easier to write it like this. This means the exact same thing, but we don't have to write the parentheses. So it's just a notational type issue. So without further ado, with this sine squared theta plus cosine squared theta equals 1, and I'm going to put a video proving this relationship, and it's actually pretty easy to prove with the trig ratios as well. But what we're going to do is this. We've got this one that we need to memorize. Commit it to memory. Commit it to memory. Got it. And then what we're going to do is I'm going to take all three of them and divide each of them by sine squared of theta. When I do that, sine squared theta divided by sine squared theta is 1. Cosine over sine, right there, is the cotangent squared of theta. And 1 over sine, let me find 1 over sine. You're saying, I don't see 1 over sine. Well, keep in mind, sine, its reciprocal is cosecant. So 1 over sine is the reciprocal. That's what that means. That is the cosecant of theta squared. So this gives us another one. Now, I know that probably threw a few people off. I can almost feel it in the internet. But if this is the reciprocal function, that's what reciprocal means. The reciprocal of 7 is 1 over 7. So that's why 1 over sine is cosecant. 1 over cosecant is sine. Well, let me do it again. Let me take sine squared theta plus cosine squared theta equals 1 and divide all three of them by cosine squared theta now. And what happens? Sine over cosine is tangent. Cosine over cosine is 1. And 1 over cosine is the reciprocal of cosine, which is, of course, secant. So what we did was take one that we know we should memorize, and I derived the other two Pythagorean trigonometric identities right there for you. It's pretty cool. Pretty cool. But I do want to take just a few more seconds in this video. And like I said, this is a video you need to stop, probably play back, watch it. You need to watch this video 10 times, 20 times. Because this right here is the first week at NC State, or possibly the second week. But let me show you one problem that an NC State student emailed me and said, I don't know what to do with this problem. The professor just didn't give me any information on it. So what I'm going to do, for lack of time, is just come up here and blah, blah, get rid of all this real quick. You love it when I do that. Look at that. Wow, it's all gone. Ha. And this was the problem. The cosecant of theta equals 2. Find the other 6 trig ratios. And this student said, I don't know what to do. I am completely lost. So let me show you what happens. Draw, when this is trig, so in this class, if you don't know what to do, you're either going to draw a triangle or you're going to draw a circle. So I said the cosine of theta, I just drew a right triangle and labeled it just like that. Wow, not that tough. That's all I did, draw a triangle. And cosecant of theta equals 2. Keep in mind what that really means. The cosecant, let me do this. What we're trying to find is the sine of theta. we're trying to find the cosine of theta, we're trying to find the tangent of theta, we're trying to find the cosecant of theta, we're trying to find the secant of theta, and we're trying to find the cotangent of theta. Now this student said, well, I've got one of them, I've got that. But keep in mind, 2 is a rational number. And we can write it as 2 over 1. Ah. When you see the word ratio, ratio means a comparison between two numbers. That's why these are trig ratios. They're a comparison between two sides. So that was one mistake the student made at NC State. Well, then he said, oh, once I showed him that, he was like, oh, okay, well then sine would be 1/2. Just like that. So in other words, the sine, some old hippie, is opposite over the hypotenuse. So what I did was label this some old hippie opposite over the hypotenuse. And you're saying, well, we don't know what this side is right here. Well, let's use the Pythagorean theorem. X squared plus 1 squared equals 2 squared. So x squared plus 1 equals 4. Subtract 1 on both sides. So x equals the square root of 3. That's exactly what x is, the square root of 3. So now the cosine is the adjacent over the hypotenuse, which means the secant is nothing more than the reciprocal of that. Tangent is opposite over the adjacent. Some will be called another hippie tripping on apples, which means the cotangent is the reciprocal of that. Now, I'm not rationalizing the denominators. This video went a little long, about 15, 16, 17 minutes. I hope you like this video. If you want more of them, message me. I will do more of them. But this is basically section 7.2, the very beginnings of trig. Very, very important. Be good to each other. Trig loves you, even if you don't love it. Bye-bye for now. And I'm cutting off the video.